Hello friends, welcome back. So now we will start normalization. This is one of the most important unit in DBMS as far as the number of questions and toughness of the question is concerned. Usually people get afraid of normalization, but it is very easy and it's an interesting topic. And if you have understood key and function dependency properly, then normalization is an easy work for you. It's just a set of some rules, few things you need to keep in mind, 2-3 rules you need to keep in mind, and with that you can able to solve all questions of normalization. Right. Now first of all we will discuss why normalization is required. What is the need of normalization and how to achieve the various normal form. There are various normal form we will be talking about starting from 1NF, 2NF, 3NF, BCNF and 4NF. We will be talking one by one what are the condition of each normal forms, and in later on sections we can talk about two important property of normalization. That one is lossless decomposition and another is dependency preserving decomposition. Now, so first let's start why we need normalization, or what is the objective of normalization. So in layman, see, normalization is going to talk about the quality of design. The design you have made in database. What are the tables, how many tables you require in each table, what are the columns you have constructed. So whether one design is better than other design, there can be multiple options for the designing of the database. Which design is better, the normalization is going to answer that question. So a design having satisfying higher normal form is always better than a design satisfying lower normal form, right? So it is all about quality of database design. We want our database design to be of good quality, right? We want, this is quality of database design. We want the database design quality should be of good level. Right. Now, the major problem in database is that database is used for effective maintenance of data, large volume of data. If we have large volume of data, we need the help of database. And if we maintain the database, if we have created the database, we expect query to be answered faster. So the most important aspect of maintaining database is that retrieval is going to be faster. If we have maintained the database but retrieval takes time, or our database is not queryable. Queryable means you are asked the questions and you will get the output. So you should design in a such a way that it is easy to answer the question. You can answer maximum questions. That is the objective, right? So we want database to be queryable. Database to be queryable, or retrieval to be fast. We want retrieval fast retrieval, or we want fast retrieval. Normalization is answer to all these things. We want database to be queryable, or we want fast retrieval. Fast. We want fast retrieval. Right. Suppose I am giving you an example. If you store the database, it is not necessary it is queryable, means you can query everything. The problem is like this. For example, suppose let's have employee database, right? It's a database of, let's say, any employee, any organization, like maybe like Adobe, PTM or Paytm or any organization, you have database. Now suppose, or the better employee can be the, okay, all right. So employee ID, let me put columns like this: employee ID, employee name, right, date of birth, salary, so many things, designation. Now we have one more column as address. Let's like this. Suppose the employee is 101 and I am only focusing on address. As of now I am only focusing on address. Rest I am not focusing. All are atomic. All columns are, employee name is atomic. One person can have one name, date of birth, salary. Address is a non-atomic column here. Now suppose its address is house number 34, right, Indira Nagar, right, Indira Nagar, Lucknow, UP, some pin, suppose. Similarly, suppose 134, right, Minto Road, suppose, just I am giving random value, Delhi, right, pin is some pin, right. Some fellow is 245 Professor Colony, suppose Professor Colony, Satabdi Nagar, suppose Satabdi Nagar, just I am giving random value, right, Meerut, suppose, or Meerut, suppose, NUP. Now the problem here lies, suppose if you want to query the database, suppose the manager or HR, people of the company, HR team is interested in those employees who belong to UP or whose address is from UP, who are from UP state. Now the problem here is that you have to read each value in the address column for each record, and then you have to come up with whether UP is there or not. UP means, UP can be word also, Kanpur contains UP. Suppose some upper colony, suppose if we have some upper colony, some address, so here you may have UP something. So problem is, or you can like Uttar Pradesh, that is not a problem. But the thing here is, in order to retrieve the query or in order to answer the query, you have to parse the value for each row. You have to read these things, complete words in the address field for each employee, and if it is anywhere it is Uttar Pradesh or UP, you will say yes. It is a time taking affair. So if we have made the data design like this, we have kept address field as it is going to be a difficult task to answer. Suppose if we want the details of all employees who are from Lucknow of UP, who belong to Lucknow of UP, so you have to search Lucknow as well as UP in the same row. That will be a cumbersome task, right? So this database we maintain, we have designed a database, but it is of less quality. It is not of good quality, or it is time taking to answer the query because of parsing requirement. So this designing is bad design. Normalization will talk about some guidelines which will make you the quality of better, and you can answer the query as fast as can be done, right? So instead of this design, what we'll go for? So we'll not go for address as it is. So instead of address, we can store, this is one simple snapshot. So house number, right, or name, whatever, a street or colony, right, then city, state, and then pin code. Right. So house number, street, colony, city, state, or pin code. So instead of that, first will what happen? House number 34 Indira Nagar, Indira here, right? This is one value. City is Lucknow, LCK, whatever, UP, and some pin, like this. So now this database is highly queryable now. So if we have to find out the people or employee who are from UP state, so state equal to, you have to write UP. And again, if you have to find UP, Lucknow in UP, so you have to say the city equal to Lucknow and state equal to UP. So now this database is queryable up to maximum extent, right? So this is one snapshot why we need some instruction, why we need some guideline to make the database as better as in terms of design quality of design. So normalization here is going to talk about quality of design, and the same thing, database to be queryable, we want fast retrieval of the data, right? So now another thing is that, suppose this is one option, this is one thing, right? So there are certain rules. If you obey rules one by one, you can achieve the better property of database design. The next thing is one more thing. Now suppose if also, let me add some more column here in the same table, and keeping a table large larger table is going to create problems in design process. I will tell you the reason. Suppose I'm not focusing on date of birth cell. We have some dependent table, dependent in the same column. Dependent, right? Dependent. Now the problem here is that suppose if we try to keep, so instead of address we have sorted out this problem. So instead of address we will go with the house number, city, state. That we have sorted out. Now if suppose the column is dependent, one employee can have 2, 3 dependent XYZ, PQR. He has no dependent. One can have no dependent. He has 3 dependent, ABC, DEF, PQ, PLM, like that. 102, 103. So what will happen? This is again also a not a good design, because one can have 4 dependent, one cannot have any dependent. Or suppose if we say the name of a spouse or other not a spouse, rather dependent only. Dependent is a proper column we want to store here. That the problem here is that it is non-atomic. It is non-atomic. And suppose we have 10 to the power 6 number of employees here in this database, and suppose out of that, or you can say child details, dependent or child details, whatever, child names, because child are normally dependent on the employee, right? So child details. So suppose out of 10 to the power 6, 10 to the power 3 number of employees do not have any child, or they are unmarried. So for them what will happen? We will, if the column is there in this table, if the value for a particular record does not exist for that column, then null is used. So if many values are null, it is a wastage of space. It is a wastage of space, because this column may not have a value for certain records. Those who don't have any child, for them we have to store null value. Are you getting? So if you try to make the table complex means many number of columns, or table large in terms of columns. If you have many columns in a same table, then there will be a problem like this. Because if you want to incorporate all information of an organization into one table, if you want to keep every activity or everything about employee in one table, you have to face the problem of null value and redundancy, right? So it will be like some here have some null value, right? So if the main thing here is, if we wish to make each column atomic, making each column atomic is very important and desirable things. So if you go to make each column unique, so one person can have many dependent, one may not have any dependent. So this column is going to make the things tougher here, and it will be a bad design. So such columns we should remove. We should, instead of not having, so if we have employee table, so we can make one more table, employee underscore dependent. And here we have employee basic details, suppose. So instead of having employee table, we can have 2 tables instead of 1. So employee dependent, here only those data will be there who have dependent. Those records will be there. So employee ID and dependent name. That's it. So if suppose 101 has 2 dependent, XYZ, 101, PQR, and this 104 has no dependent, so his entry or her entry will not be there. So here we'll remove dependent from the original table, and we are saving null values. If many entries are null, if maximum entries are null, then no worth to store this column in this particular table. So let's separate out this column, and we'll make a new table for this particular column. So instead of 1 table, we can have 2 tables. That will be better design, right? Now, if let's have another example. So here we will have employee ID, e-name, basic things, others, and dependent we have separated out. So those employees for whom there is no value for dependent, their entry won't be there, and we can do the join, because employee ID is common which is a foreign key here, so we can retrieve the information. Retrieval is not a problem here. We want to save null. So there are three things. See, we want less null. We want the desirable thing in database design is null value, redundancy, and anomalies. There can be this problem of null values. These are undesirable things. We want to get rid of them, or we want to control them. So undesirable things in database. Undesirable thing. We don't want such things, or we want as minimal as undesirable. One is null value. If we have null value, it means it is a wastage of a space. And null creates also problem. Suppose if a column is numeric and there are many rows having null values, so null is not equal to 0. So if you perform aggregate operation like average, find, max, mean, then null will create issue. So either one problem is that if you have null, we don't count that rows, just leave that rows while doing the summation, right? Otherwise, if you count, it is not equal to 0. So null creates problem while doing some arithmetic operation, right? So we want the database that should have as minimum as null value. Null value. Then another issue is redundancy. We want less redundancy. Redundancy means storing the same data multiple places. It's unnecessary wastage of space. We should not have redundancy as much as we can, or as much as we can have less redundancy. We want redundancy to be minimal, right? And anomalies. There are three types of anomalies. One is insert. So anomalies means problem arises due to some operations. So it can be arises due to insertion anomalies, update anomalies, or it can be due to deletion anomalies. Right? Insert, update, or delete anomalies. Right. So we want these things to be less, undesirable things. So we want to minimize them as minimum as. We want to. We cannot say no null value. We can't say no null value. We can't say no redundancy. It is not possible. For example, null will come. Suppose we store employee name. Instead of name, we store suppose first name and last name, or first name and surname. Suppose if person name is Mohit, no surname. So what in his case? We have to store null. Because if a value does not exist for an employee, we cannot enforce. So in that case, null has to come. But our objective is to minimize those occurrences of null. If null can be arises due to two reasons. Either the value is missing or value does not exist. Suppose for some person, right? Suppose we have employee table. See, null has to come. We cannot say no null value. Null will come because of the situation. Suppose employee ID, first name, last name, and mobile number. Suppose, or mobile number. Right. Suppose for a particular employee, 101, first name is ABC. Here it is null. Here it is null. What we can infer? So a person might not have last name. If many student has only one name, first name, Avas, Abhishek, no surname. In that case, the last name will be null. But if mobile is null, what we can infer? Either the mobile number do not exist for him, means he or she does not have mobile number, or value is missing. So null can be used if a column has null value. It means it can give two things. It can be due to two possibility. One is the value does not exist, or value is missing. Null means if a column has null value, null means two things. Either value does not exist, right, or value is missing. Either value does not exist or value is missing, and we don't know what is the case. It is very difficult to convey which one is the case. So if mobile is null, it means it may not, person may not have mobile number, or he has the or she has the mobile number, but it is not available as of now, it's missing. Anything can happen. But suppose if first name of a person is null, then it is a case of missing, because a person must have first name. One may not have last name, but person must have employee must have at least first name. So this null indicates the missing, sure. But this null can be either missing or does not exist. We don't know. Anything it can happen. So this is a scenario where null comes. So we want these three things to be minimal. And normalization will guide you the process. If you follow the process, if you follow the guidelines of various normal form, we will end up with the better design. Right. So what we so far we have seen, so far we talked about the database to be queryable. If we keep, second thing we talked about, if we keep all columns, all information of a particular table in one table of, or suppose employee table, if you want every activity of employee to be maintained in one table, then the problem of null value will be there. We want less null values, so better go with decomposed relation. Instead of one relation, we can have two relations. Now let's have one more example for this category, for null values and others. Right. Now suppose a student in a university, a student table. So roll number, name, right, and marks, SGPA. Right. Now problem will be that SGPA will be for various semester. If you wish to store all the marks, so marks 1, or we can say SGPA semester 1, marks 1. Suppose there are 8 semesters, so marks 1, marks means SGPA, marks 2, and suppose mark 8. See, this way I am also trying to explain you. Suppose if you want to keep every information of a student table in one relation, then also certainly you have to also store the marks. Marks in first semester, marks in second semester, marks in 8th semester. Suppose 8th semester marks one can have in BTech curriculum. Now if you try to incorporate all activities, everything, every data about a student in one table, that is a student table, what will be the problem? See, the problem, very big problem here. Suppose one student is roll 101, and if the student is in second semester, if the student is in second semester, so for him or her only marks 1 will be available, marks 2 to marks 8 will be null, marks 2 to marks 8 will be null. So all this, if you keep all information here, 8 column for each marks or for each year, suppose if it is a graduation, normal BA, BSc graduation, so marks in first year, marks in second year, marks in third year, so there will be 3 column. But for those students who are in first year or who are in second year, for them there will be must 1 or 2 null values. For first year there will be 2 null values if result is published. For second year student there will be 2. For first year there will be all null, because if a student is in first semester, he don't have, because marks 1, marks 2, marks 8 all will be unavailable, because he has to first write the paper after the end of semester. So for them all the values will be null. So it is what we have just make the design in such a way that causes many null values. So instead of this, it is a bad design. Instead of this, instead of storing all information in one table, better go with other tables, many other tables to store each information separately. So this design will be bad design. If a student is in second semester, this will be null, this will be null, all null and null. So it's just a wastage of space. So instead of this, we will go with a student table, and here we will have basic details like roll, name, right? Then we can have marks semester 1. So here we can have ROL and SGPA like that. So those students who has semester 1 marks available for semester 1, their entry will be here. Now similarly we can have, if we are looking for a marks table, marks semester 2. So only those entry will be there who has marks in semester 2. Similarly we will have marks 8. So in this way we are going to avoid null values, because for those students whose marks is available in that particular semester, their entry will be there, otherwise no null will be there. So large table creates lot of problem, or it have many null values issues, and it can have also redundancy problem. So better to go with a smaller tables. So normalization is all about just in one line, instead of having a large table we can go with a smaller tables. So large tables need to decompose into smaller tables to remove these undesirable things or to minimize them. Objective of normalization is to minimize. We cannot say zero null value. Zero null value is not possible. Only our objective is to minimize these null values as much as we can. Right. So if you follow the series of guidelines of normalization, it is all about how to decompose a large relation into smaller relations to achieve desirable thing. Desirable thing means minimum null value, minimum redundancy, and no anomalies or minimum anomalies. So let's go for a break, and after break I will talk about the formal ways of normalization, what is actual definition and how to carry further ahead.